Hi everyone and welcome to this tutorial session. In today's tutorial, we want to solve this Maths Olympiad question. 3 to the power x multiplied to 5 to the power x squared is equal to 15. We want to find all the real solutions, that's all values of x that are real numbers that will render the left-hand side of this equation equals the right-hand side. Please watch the solution from the beginning to the end because we will be giving ample explanation to every major step that we'll be taking along the way. Thank you. Okay, 3 to the power x multiplied to 5 to the power x squared is equal to 15. The left hand side is a product, so it will make sense if we write 15 as product of its factors. And the choice that we want to take, remember 15 can either be 1 times 15 or 3 times 5. The choice that we'll make here will be 3 times 5. Why? Because we have a base here 3, we have a base here 5. This choice will make our work go faster. So we'll write 15 as 3 multiplied to 5. So our expression now becomes 3 to the x multiplied to 5x squared is equal to 3 times 5, or right cross 3 times 5. Okay, now from here we divide both sides by 5. We divide both sides by 5. We have 3 to the x multiplied to 5x squared divided by 5 is equal to 3 times 5 divided by 5. 5 here cancels, and we have 3 to the x, 5 to the x squared all over 5 is equal to 3. Now, we also divide both sides by 3 to the x. We want to bring everything concerning 5 to one side and everything concerning 3 to the other side. So we divide now both sides. Divide both sides by 3 to the x. So we have 3 to the x, 5x squared all over 5. So since we are dividing both sides by 3 to the x, we just do this multiplication. 3 to the x, 3 to the x. Now 3 to the x, or what are we doing? This here is 3. 3 all over 3 to the x. We have 3 all over 3 to the x. 3 to the x cancels 3 to the x there. And so we have 5 to the x squared all over 5 is equal to 3 all over 3 to the x. Okay, so now we have the both this left hand side in terms of 5, the right hand side in terms of 3. So we can easily write the expressions on both sides in index form. Remember, a to the m all over a to the n is the same as a to the m minus n. The power above minus the power below, since the bases are the same. All right, 5 is the same as 5 to the power 1, 3 is the same as 3 to the power 1. And so when we apply this law, here we'll have 5 to the x squared minus 1. That power there, x squared minus this power, will be equal to 3. The power up is 1, the power down is x. Okay, so we have expressed the left hand side in index form and the right hand side in index form. Remember, we're asked to solve for x. X is found at the powers. There is a mathematical tool that will enable us bring down powers. That tool is called logarithm. So we take logarithms of both sides. We take logarithms of both sides. Log of 5 to the x squared minus 1 is equal to log of 3 to the 1 minus x. Now, the law of logarithm says log of a to the n is equal to the power will come in front, will become n log a, will be applicable here because we have powers there. You will now bring down this power and we'll obtain x squared minus 1, this power, into log 5. This power also comes down, 1 minus x into log 3. When we apply that law of logarithm. Okay. Now, let's divide both sides by log 5. Let's divide both sides by log 5. So we have x squared minus 1 log 5 all over log 5 is equal to 1 minus x log 3 all over log 5. We see log 5 cancels off there. And so we are left with x squared minus 1 is equal to 1 minus x log 3 all over log 5. Okay, this is where we've gotten to. That's the point where we've gotten to. Now, if we look at this expression here, this expression is actually a difference of two squares. Okay, let's write that out clearly for us to see. X squared minus 1 can actually be written as x squared minus 1 squared. Okay, 1 squared we know is the same as 1, but we're writing it in this manner in order to see the difference of squares. It's actually a difference of squares written in a disguised form. So here we can now apply the difference of squares identity. Okay, so we know that x squared minus 1 will be the same as x minus 1 into x plus 1 when we apply the difference of squares identities. All right, so this left hand side will be expressed as such. Now look at 1 minus x. On the left hand side we'll have x minus 1, but we can transform this into that by simply putting a negative outside, and then we'll have x minus 1. All right, 1 minus x is the same as negative into x minus 1. All right, because we will try to open out this parenthesis, we'll get back that one. Look at it. Negative multiplied to x is negative x. Negative multiplied to negative 1. Negative, negative, positive 1. All right, so our aim is to have the factor x minus 1 on both sides of our equation. So applying this now here, we'll now write our left hand side as this. All right, so we're going to have x minus 1, x plus 1, okay, will be equal to, now in the place of 1 minus x, we're going to write negative x minus 1 log 3 all over log 5. All right, we'll have x minus 1 on the left hand side, x minus 1 on the right hand side. Now, let's carry all of this, since we have this negative sign, let's carry all of it and take from the right hand side to the left hand side. That way, we'll obtain a plus. This negative sign will become plus. So we'll have x minus 1 into x plus 1. Coming this way, we'll have plus x minus 1 log 3 all over log 5. Now the right hand side is 0. This is our new equation that we get. We have x minus 1 common, so we can factorize it out. X minus 1, we can factorize it out. When we remove x minus 1 from here, we have x plus 1. When we remove x minus 1 from here, we have log 3 all over log 5. Okay, this is the new equation that we get. Now, what do we see on the left hand side? On the left hand side, we have the product of two expressions giving us 0. Okay, we know what that means in mathematics. This expression multiplied to this expression giving us 0. So either the first one is 0, either x minus 1 is 0. If that is the case, it means x is 1. So our first solution is x equals 1. Or the second expression, x plus 1 plus log 3 all over log 5 is 0. All right. Now, This simply means x plus 1 plus log 3 all over log 5 is 0. We'll carry everything from the left hand side to the right hand side. We'll obtain the value of x as negative 1 minus log 3 all over log 5. Okay, this gives us our second value for x. So we've gotten two solutions. They are all real numbers. Remember, we're asked to solve in the set of real numbers. X equals 1 and x equals negative 1 minus log 3 all over log 5. We can always check. You can check, okay, by simply putting x equals 1 in the left hand side here to see if we obtain the result on the right hand side. Okay, so we have 3, we'll have x to put 1 multiplied to 5, 1 squared. This is simply 3 raised to the power 1 is 3. 1 squared is 1. 5 raised to the power 1 is 5. That gives us 15, which is our right hand side. The same thing can be done when we put the value of x equals negative 1 minus log 3 all over log 5. Working with our calculators, we'll see that the left hand side will agree with the right hand side. So our two solutions are correct.